So welcome back to functions, and this is your Cloudmental Girish. So the topic is classification of functions. Classification of functions. Let's classify the different types of function we are going to deal with. The first one is the constant function. Constant function. What do you mean by constant function? Hmm? A function which does not change as its parameters vary. That is the function whose rate of change is zero. In short, a constant function is a function that always gives or returns the same value. Or let k be a constant. Let k be a constant, and then the function f of x equal to k for all x element of r. For all x element of r is known as the constant function, and the domain of f of x or the constant function is r. Domain is r. Domain is r. While the range of f of x will be equal to the same, that is k. Range will be the set of k. And now the graph of the constant function will the graph of the constant function will look like this. That will be parallel to the x-axis. Okay, so this is the graph of a constant function. And now moving to the next type of function, that is the polynomial function. Polynomial function. Polynomial function. The function y equal to f of x, that's equal to, I can write it in the general form, a0 x raised to n, a0 x raised to n plus a1 x raised to n plus n minus 1, a1 x raised to n minus 1 plus etc. up to an, where a0, a1, a2, etc. an are the real coefficients, and n is a non-negative integer, which is known as the polynomial function. This one is known as the polynomial function, and a0 cannot be equal to 0. a0 cannot be equal to 0. Then the degree of polynomial is the n. The degree of the polynomial is the n. Okay, and the domain of f of x will be equal to r. Domain will be r. Domain is r, equal to r, while the range varies from function to function. The range will be varying from function to function, so we can say that now. The next type, that is rational function. Rational function. Rational function. If p of x and q of x are polynomial functions, and where q of x not equal to 0, then the function f of x is a rational function that can be written as p of x by q of x. P of x by q of x is known as the rational function, and domain of the rational function is, it cannot be never be 0. So this cannot be 0. So domain will be equal to r minus set of x such that q of x, r minus x such that q of x such that q of x equal to 0. Q of x, we can have the value of 0 for the q of x. Okay, so this is the domain of f of x, and the range varies from function to function. So the next one, it is irrational function. Irrational function. Irrational function. The function containing one or more terms having non-integral rational powers of x are called irrational numbers. Okay, they are having non-integral rational powers. Okay, rational powers are called the irrational function. So for example, y equal to f of x equal to 5x raised to 5x raised to 3 by 2 minus, that is a non-integral rational powers, non-integral rational powers, minus 7x raised to 1 by 2, the whole divided by x raised to 1 by 2 minus 1. So here the domain that varies from function to function. So we can write the domain in this case generally. It varies from the function to function. Also the range also is varying from function to function. And the next type is identity function. Identity function. Identity function. Okay, the function f of x equal to x. F of x equal to x for all x element of R. For all x element of R is known as the identity function, and it is the straight line passing through the origin and having slope unity. So that is the sorry. Okay, so the graph is, it's a straight line passing through the origin and having a slope of 1. Oh, sorry. Sorry. It's moving like this. Okay, a little crowd. It's not a problem. Do that, and that's the function or the graph of this function. And now the slope will be 1. That is why here y must be equal to x. That is the equation of this graph, y equal to x. So the slope will be equal to 1. And that's, and here the domain will be equal to domain and range both are equal to R, or the real numbers. Domain and range are both equal to domain and range both equal to R, that is the real numbers. And now the next function, that is a square root function. Square root function. Square root function. Square root function is the function that associates every positive real number x to plus root of x is called the square root function. It's a function that associates every function or the every positive real number x to its root, that is root of x, is called the square root function. That is f of x equal to root of x. This is the square root function, and the graph will look like this. Starts from the origin and it climbs and goes out like this. So this is the graph for square root function, that is y equal to root of x. And okay, this y dash y x dash x, that's okay. And now the range will be the range of f of x. Range of f of x will be equal to from the 0 to infinity. 0 to infinity can have the values when 0 to infinity. That function have the value from 0 to infinity. Okay, and that's it. So okay, domain can be equal to, that is the positive real numbers. Okay, domain is the positive plus r, domain plus r. I have already told that domain is plus r. And now the next function, that is exponential function. Exponential function. Exponential function. Okay, a function of the term f of x equal to a raised to x. A function of the term f of x equal to a raised to x, that is the exponential function, and a is a positive real number and is an exponential function. The value of the function depends upon the value of a for 0 less than a less than 1, less than 1, and the function is decreasing, and for a greater than 1 the function is increasing. Okay, the value of the function depends on the value of a. This for a or 0 less than a less than 1, the function is decreasing, and for a greater than 1 the function is increasing. Okay, so here the domain will be the domain will be equal to r, and the range can have the values from that's 0 to infinity, 0 to infinity, so 0 to infinity. So let's draw the graph of that function. Let's increasing and decreasing function. First one, it is decreasing function for 0 less than a, or a between the 0 and 1, 0 less than a and less than 1. So that's a decreasing function. Decreasing function is like this. It is y equal to a raised to x. This is the equation of the polynomial function, and now the graph will be like, so graph is like this, and it here let this intersects at 0 1 0 1. This point is 0 1. Okay, and now so this is the decreasing function is between 0 and 1, and now the increasing function or the increasing value will be for the a greater than 1, a greater than 1, and will be like this increasing function. So this is the increasing function or increasing exponential function, y equal to a raised to x. This a is greater than 1. For a less than 1, between 0 and 1, then this is a decreasing graph like this, and for a greater than 0, then the graph will be like this. There is no such bends here. This is a mistake of drawing. And now moving to the next type of function, it is the logarithmic function. Logarithmic function. Function f of x equal to log x to the base a, log x to the base a, where x comma a is greater than 0, x comma is greater than 0 and a is not equal to 1. A is not equal to 1. It's known as the logarithmic function. And the domain of the logarithmic function is domain of f of x is equal to from 0 to infinity. This is open interval 0 infinity. And the range will be, because the value cannot be equal to 0, the value of the x cannot be 0. That's because that's because the it is open interval here, and the range will be equal to the r. Range will be r, real numbers. And now the graph for the function will be different for 0. That of this like that of the previous polynomial function. It is different for both the limits, that is for the a for the 0 less than a less than 1 and a greater than or a less than 1. Okay, 0 less than a less than 1, and here a less than 1, not a greater than 1 like the polynomial function. So the graph is different. The graph will be like this. Okay, here the intersection point is 1 0 1 0, and here the graph will be increasing. This was decreasing, and this one is increasing function. The same point 1 0. So this is the graph for logarithmic function, which is somewhat same as that of the polynomial function. It is because it intersects at the x-axis here, but here it intersects at the y-axis. Okay, that's the difference. And now moving to the modulus function. Modulus function. Modulus function. The function y of x, y equal to f of x, y equal to f of x, which is equal to mod of x, is known as the modulus function. Y you can define it otherwise as y equal to f of x equal to mod of x. Mod of x can have the value plus x if x is greater than or equal to 0, and minus x if x is less than 0. And the domain of f of x is, domain will be x element of r, and range of f of x is range of f of x equal to, from it can have the values from the 0 to closed interval 0 to infinity. So that's it. And the graph will be like a shape of V touching the origin if the function is y equal to x, mod x. That is, here this graph is, in the left side it is y equal to minus x, and the right side y equal to plus x. So that's it. And now the properties, there are some properties for modulus functions which are important. For any number, any real number x, the root of x square will be equal to mod of x. Root of x square will be equal to mod of x. And the second property, if a and b are positive real numbers, then the first thing, it is x square is less than or equal to a square, which implies and implied by mod x is less than or equal to a. Mod x is less than or equal to a, which implies and implied by minus a less than or equal to x less than or equal to a. Okay, that's it. And the second subproperty, that is x square is greater than a square, is greater than or equal to a square, which implies and implied by mod x is greater than or equal to a, and that also implies and implied by minus a, or I mean x is less than or equal to minus a, or x is greater than or equal to a, so C, that is a square is less than or equal to x square less than or equal to b square, which implies and implied by a is less than or equal to mod x, which is less than or equal to b, and which implies and implied by x element of minus b closed interval minus b minus a union closed interval plus a plus b. So that's it. And the third property now is that mod of x plus or minus y is less than mod of x plus mod of y. It's always less than or equal to mod x plus or mod y. And now the fourth property is mod x plus y is greater than or equal to mod of mod x minus mod y. Okay, that's it. Now moving to the next function, that is greatest integer function. Otherwise called the step function, and such that step function. It is because of the graph looking like that. Greatest integer function. For any real number x, the greatest integer function is denoted by the x in the square bracket, and is equal to the greatest integer less than or equal to x. It means the greatest integer less than or equal to x. The integer. If the x is in decimal, we must take the integer, which is less than or equal to x, not greater than. And in general, if n is an integer and x is any number satisfying n less than or equal to x less than n plus 1, n sorry n less than or equal to x less than n plus 1, then the greatest integer of x will be equal to n. It is also known as integral part function. Okay, and now for example, uh, if 2 is less than or equal to x less than 3, then the greatest integer of x will be equal to 2, equal to 2, equal to 2. Okay, and now domain will be equal to, domain can be anyone, domain can be any number, that is any number which is in the real number set. So domain is R. Okay, domain is R, and the range will be only integers, range will be the integers, range equal to I. Okay, I. Now if the function is like this, 2.1 or 2.5 something, 2.1, then what will be the function, the value of the function? It will be simply 2. Okay, or if the one is 2.6 or 2.5, it is also 2, this integer. Okay, that's, and now the graph will be a little different. That is like this. If this is 1, I use another one. Okay, this is 1, 2, 3, and 4 and 5. Okay, so let's number here, 1 2 1 2 3 4 5. Here it is -1, -2, -3, -4, -5, and so on. So from upwards it is 1 2 3 4, and here it is -1, -2, -3, -4, and the graph will look like this. That is from including 1, it is integer, 1 is an integer, so it is rounded here, and towards the 2 it is constant, and we are not taking the 2, it is just rounded like this. And from 2 to 3, from 2 to 3, the graph of function is like this, and at 3 it is a whole. Okay, then from 4 to 5, or 3 to 4, like this. Okay, and from 4 to 5, like this. Okay, and in the negative side, this graph is like this, from 0 to, from 0 to, I am writing here. Okay, it's actually here, 0 to 1, 0 to 1, it's like this, and from that to -2, then -3 to 3, like this. So this is the graph. how it look like. It is like a step, right? It like a step. Okay, so that's a reason why it is called also as the step function. Step function. Okay, so that's it. And now there are some properties of the general greatest integer function. That is the that if n is an integer and x is any real number between n and n plus 1, then the greatest integer, that is of minus n is equal to minus of greatest integer n, minus of greatest integer n. The second one is that if greatest integer x plus 1 is equal to greatest integer of x plus n, okay. And another property, third one, is that the greatest integer of minus x will be equal to minus of x minus 1, minus of x minus 1, if x is not an integer, okay. And now the fourth property, the greatest integer of x plus y is greater than or equal to greatest integer of x plus greatest integer of y, okay. And now the greatest integer of x is always greater than n, which implies x is not always, which implies x is greater than or equal to n plus 1, okay. And now next one is greatest integer x is less than n if, or it implies x is less than n, okay. And now the next one, the seventh, greatest integer x plus y is equal to greatest integer of x plus greatest integer of y plus x minus greatest integer of x, okay. And for all x y element of is not x y element of R. The ink is not showing here, maybe any defect, okay. And the last property is that the greatest integer of x plus the greatest integer of x plus 1 by n, plus greatest integer of x plus 2 by n, 2 by n plus etc. up to plus x plus n minus 1 by n, that will be equal to nx, the greatest integer of nx, n element of natural numbers, okay. Now the next function is Sinum function. So what is that function? The function defined by the following rule, that is like this: f of x equal to the modulus of x by modulus of x by x, that is equal to minus 1 if x is less than 0, and 0 if x equal to 0, and plus 1 if x is greater than 0, and is called the sine of function. And the graph will look like this one, that is from this is origin, so this will be 1, okay, 1, and here is minus 1. Then here we can make it a hole and draw a graph from that towards right. It will extend towards entity. So here this y equal to the graph, the equation of the graph is y equal to 1 here, and below there from here minus 1. Okay, this is minus 1, this one, and from this to the left, and it extends to infinity. Not entity here, this to the infinity, okay, into the infinity. And the y, the graph, the equation of the graph here is y equal to minus 1, and here x is less than 0. Here x is greater than 0. Okay, so this is the graph. For the graph at x equal to 0, this will be the value. Okay, so I can make it a dark dot. Okay, so domain of sine function is R. Domain is R, and the range will be only minus 1. Range equal to set of minus 1, 0, and 1. Okay, so let's move to a problem. So the domain of the function f of x equal to 1 by root of greatest integer x square minus greatest integer x minus 6 is what? So the f of x is defined by this one, that is root of this function. So it must be greater than 0, because it is the root, that is the square root. That square root must be greater than 0 in order to become a real value, otherwise it will be a complex rate. So we want a real root, so it must be greater than 0. Okay, so we can write that is a condition, or f of x is defined by that. So that is x square greatest integer x square minus x minus 6 greater than 0. So I can split it. So I can split by writing or factorizing. We get the greatest integer of x, minus 3 of greatest integer of x plus 2. Okay, and which is greater than 0. So we can write here the greatest integer x is less than minus 2, and or is less than minus 2. Okay, minus 2, and or greatest integer x is greater than 3. greater than 3. So from the first statement, that is x less than minus 2, it can have the values of the negative values, right? Like the x can have x equal to minus 3, minus 4, minus 5, and etc. up to infinity. So and then the x greater than greater than 3 means the x can have the values from that is x equal to 4, 5, and 6, so many things. uh, and so it implies that domain of f is from domain of f, here is x is greater than or equal to 4, it's greater than or equal to 4. Okay. And from here, okay, we can write here domain of f is minus infinity, not taking minus 2 here, so minus open interval minus infinity minus 2, open interval minus infinity minus 2, union union here it is from 4, so close interval for infinity. Okay, so which is the option, right option, minus infinity minus, oh, so the option A is the right answer. Option A is the right answer. So moving to next part, it is algebra, or I mean of real functions. So algebra of real functions. Of real functions, and let f from, okay, let f from x to r, and g from x to r be any two real functions, then, and x is a subset of r, x is a subset of r, then the first function, first algebra, or the first operation is addition 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 of real functions, that is f plus g of x, f plus g of x is equal to f of x plus f of x plus g of x. Okay, and in the subtraction that is f minus g of x, will be equal to f of x minus g of x, and the multiplication by a scalar. This is next one, is multiplication by a scalar. Multiplication by a scalar. Okay, and that is, if alpha is the scalar here, alpha is scalar, alpha f of x, equal to alpha of f of x, okay, as alpha and x is element of r, and the multiplication of two real functions. How to multiply two real functions? Multiplication of two real functions. Okay, then fg of x is equal to f of x into g of x. Simple. Okay, and now the quotient. How to take the quotient of two real functions? Is f by g of x is equal to f of x by g of x. Simple. F of x by g of x. And here g of x is not equal to 0. That's all. And now moving to the next topic, that is inverse function. Inverse function. So let f be a function, a defined function from a to b, such that for every element of b there exists a image. Let y be an arbitrary element from the element of b, then f being on to there exists an element x element of a, such that f of x equal to y, f of x equal to y. Okay, and also f being 1 1, this x must be unique. Okay, f is also f must be onto, and f must be 1 1, and being 1 1, this x must be unique. Okay, and this thus for each y element of b, for each y element of b there exists a unique x element of a. For each y element of b there exists a unique x element of a, such that f of x equal to y. So we may define a function that is f inverse from b to a, f inverse from b to a, f inverse from b to a, that is f inverse y, f inverse y is equal to x, which is which implies and implied by f of x equal to y, f of x equal to y. Okay, the above function is f inverse. The above function f inverse is called the inverse of f. F inverse, this is the inverse of f. Note that inverse of bijective function is also a bijective function. Okay, that will be also a bijective function, and if the inverse of f exists, then f is called an invertible function. F is called an invertible function, that is a function f is invertible if and only if it is 1 1 and onto 1 1 and onto. So let's look at a problem. Let f from R to R be a function defined by f of x equal to 2x minus 3, then f inverse x is equal to. So first let's take f of x equal to y, so y equal to 2x minus 3, y equal to 2x minus 3, right? Yes. So from this we can write 2x, we can isolate x, that is 2x equal to y plus 3, and x equal to y plus 3, by 2. And for inverse, for finding inverse, we must change the x here with y, x here with the I mean the y here with the x, y here with x, that is x plus 3 by 2, x plus 3 by 2. So inverse is this. So our option B is right answer. And moving to the next topic, that is composition of functions. Okay, let a, b and c be three non-empty sets. Let f from a to b and g from, that is f from a to b and g from b to c be two mappings or functions. Then g composition f, why this, g composition f of or from a to c, then this function is called the product or composite of f and g, given by, you can show that by a diagram. If this is a, the set a, okay, then x is from that a, and the set b here and set C here. So f is a function from a to b, so function f is a to b, and f a function g is from b to c. G is from b to c, and that is y equal to f of x, and here z equal to g of f of x, okay, g of f of x. So the direct composite function is GOF, and that is GOF f of x is G composition f of x is equal to G of f of x, okay. So this value for all x element of A. Got it? So GOF or G composition f exists if and only if the range of f is a subset of domain of G, Similarly, f composition G exists if the range of G is a subset of domain F. Okay, and the properties of composition of function are first one, it is the composition of function is not commutative. That is f for G is not equal to GOF, okay. And the next one, it is not also, I mean, composite function is associative. It's not commutative, but it is associative. It's f4 GOH is equal to f4G of composition H. Okay, f composition G of, or f composition G composition H. Here f composition G composition H is equal to f composition G composition H. Okay, that's the associative law. And the third property is that the composition of any function with the identity function is function itself. The composition of any function with that identity function is the function itself. So it is if f is from a to b, then f composition IA will be equal to IB composition F, that is equal to F. Okay, so that's it. So now let's move to the question. If f of x equal to ax square plus b the whole cube, then the function g such that f of g of x equal to g of f of x is given by which function? So this question we can just assume anything and prove that it is correct. So I am taking the last one, option D, as g of x. Let g of x equal to x raised to 1 by 3 minus b by a. I don't know if it is correct, but I am taking this x raised to 1 by 3 minus b the whole raised to 1 by 2. So from this we can write f of g of x. You must check that if it is correct. Oh, it is not coming. The ink is not coming here. F of g of x. F of g of x is equal to f of what happened, I think the software has crashed. So f of x raised to 1 by 3, x raised to 1 by 3. Oh my god, my pen is really bad. Ah, so x raised to 1 by 3, not 2 raised to 1 by 3, x raised to 1 by 3, x raised to 1 by 3 minus b, f of x raised to 1 by 3 minus b by a, the whole raised to 1 by 2, whole raised to 1 by 2. That is the f of g of x. G of x is this one, so f of g of x must be f of x raised to 1 by 3 minus b by a raised to 1 by 2. So here we can apply this in the, or this x value. So here x will be this one, so this apply this in this equation f of x. So we get a of in the place of x we must write this one. Okay, so in the place of x we write x raised to 1 by 3 minus b by a the whole raised to 1 by 2 the whole square, so that will be cancelled out, and so we get this one, and plus b, right, plus b the whole cube. Man, my pen is really bad. Okay, raised to 1 by 3, oh, raised to 3. Okay, so this is what we got, and now the solving this we get the b a cancelled out, and b plus minus b and plus b cancelled out, and x raised to 1 by 3 the whole raised to 3, right, x raised to 1 by 3, x raised to 1 by 3 the whole raised to 3, so that will be equal to x. So we got f of g of x is x, and now we need to find g of f of x, g of f of x, right. It is to prove, I have taken the fourth one, so prove that we need to find f of g of x and g of f of x that must be equal to this one, equal to the they must be equal, otherwise it is not the right answer. We need to go for another one, but I am now looking for the fourth one. So g of f of x is g of f of x equal to g of f of x is ax square plus b the whole raised to 3, so g of f ax square plus b the whole cube. Okay, whole cube. And now, so applying that a in the place of ax square, in the place of x in g of x, that is there ax square plus b the whole cube. Okay, we are applying ax square plus b the whole cube in the place of x here, so we get ax square plus b minus b I am applying directly, minus b by a the whole raised to 1 by 2, the whole raised to 1 by 2, that is equal to, we get x square raised to 1 by 2, x square raised to 1 by 2, and that will be equal to x, so here we know that f of x equal to, or we found that f of g of x or g of f of x, like in the question okay, like in the question f of g of x is equal to g of f of x, okay. So g of x is, so our assumption was right, g of x equal to x raised to 1 by 3 minus b the whole divided by a, that is a raised to 1 by 2, that is the correct answer. So option D is the right answer. Okay, now to know more about the Cloud Mender, visit our website. You can Google by typing Cloud Mender Gaurish. Site appears as the first result, and or simply search Cloud Mender and you will get the site as the third result. And also you can follow us on different social media platforms, and you can follow us on Instagram, and you can follow on WhatsApp. I have created a WhatsApp group for discussions on different doubts you have, and the links are given in the description box. Also a Telegram group for discussion and the same purpose, and a channel is also formed for giving off your learning steps, and all the links are given in the description box. You can check it later. You can also ask your doubts as comments in YouTube, and if you want more videos which would be uploaded in the coming days, please subscribe our channel and press that bell icon for getting notifications on time.
Hope you guys understood the topic. Thanks for watching my video. Always be free to ask questions. Subscribe to my channel for more videos. If you like this video, share it with your friends. See you guys.